Okay, hi, good morning, everyone. So, give me a second. Can you all hear me?
Yes, I can hear you. We can hear you.
Good morning,
Yes, I
everyone.
can hear
Okay,
you.
yeah,
Morning,
thanks.
morning.
Yeah, good morning. Let me- One thing, please help me mute all if someone actually did not actually turn it off. Okay.
Yeah, sure.
Okay, we are 5 minutes into the call, so I shall actually start off. Okay. So thanks for joining this session early this morning. So for this launch, which I actually sent out the product announcement letter last week. So this is actually for the Fluke Sound Beacon, FLK SB140. So over here you can see this. This is actually the unit that we actually launched. Yeah. So this is what we call the sound beacon, and basically in terms of the intent of this new product is actually we are actually trying to revolutionize the leak detection, because most of the time when we actually visit the customers or your customer applications, there might be always instances whereby customers are trying to test in the unpressurized system. So without the pressure, it's difficult for us to actually use our acoustic imager to actually detect or to help customers to actually locate or pinpoint where the exact locations of the leakage area. Okay, so by having this SB140 sound beacon device, it helps us to actually revolutionize the tightness testing application. So this is actually the focus area that we are actually going to. So it's very different from our typical, probably your customers, industry or applications that you have probably actually sold the acoustic imager to. Okay, and this one we can actually work in hand in hand together with our flute acoustic imager. There's the i500, 905, 915, because over there, once you actually do the firmware updates, which I'll actually cover later on, it has the beacon mode to actually make it more seamless and easier for you to actually work hand in hand together with these sound beacon accessories. Okay. So just to emphasize, just remember that when you use this sound beacon, okay, it's mainly to test for tightness testing, for seal integrity, for especially for non-pressurized, for example, vessels or compartments or a certain enclosure. Yeah. So this is something whereby, for example, when you go into custom base, usually it might not be actually your typical facility maintenance group of people that we are going after. It would be a totally different department of end users that would be very much interested in this area. For example, could be the QA/QC quality control areas for the aviation or the automotive sector, railway, clean rooms, or even marine sector. Yeah. So in this session, I will touch on this product introduction for the first few slides before actually I will share some applications for you to actually explore, but we are not limited to those which I actually shared, because it really depends on your customers' business needs and what they're actually producing and how critical those items are. And that's where you can actually propose whether this actually fit in to actually help them to resolve any of their seal integrity challenges. Okay. Okay. So in terms of our, if you have visited your customers, you might actually encounter customers actually sharing with you saying that, okay, they have an unpressurized system, but they need something that is actually faster, accurate to actually inspect the leak locations. So typically, same as in the pressurized scenario. So customers might be actually using traditional approach, could be bubble testing, using tracer gas to actually inject, and also using those like luminous dye penetrants to actually test for the leak location. So there are actually a lot of different traditional approach, but many a times when we actually investigate or go into this area, it's very time consuming in terms of from the the time whereby they have to set up to actually do testing, or some process they have to actually move into a different factory scenario in order to have that facilities to get it tested. Okay. So overall, these the key findings from most of the customers, whereby the feedback about their challenges. Okay, so that is where we are coming up with this air tightener solution with the SB140. Okay, so it works hand in hand with our sound acoustic imager to provide them well all-rounded solutions for the customers. So customers who needs to tackle the pressurized systems, they can actually use the acoustic imager on its own. For those areas whereby they don't have pressure, they want to do troubleshooting, to do testing, to do during their design phase, etc., they can actually utilize this to actually help them to actually diagnose, okay, the fault location. So when we look into in terms of this industry, for the tightness industry, okay, so different customers, industries, you will actually encounter different type of equipment, production systems, and in terms of what we actually face, you actually notice that the type of seal that they have actually installed are all very different. Okay, so here are just some pictures or images just to show to you. So some customers can have this when they're producing something. They have this welding machine, so they do the bead welding, okay, to make sure that these two joints are actually joined together. Yeah, so over here, you can see that it's actually a flange. So there's actually a gasket in between to actually make sure it's an airtight seal. So this is actually something which you might be familiar. Okay, there's always this black seal thing over here that has been designed and installed, okay, precisely to actually fit into the design of that door, for example, or the window sill, to make sure that's airtight. And this has been used for different type of application area, which I'll cover on. So example, in the clean room industry. Okay, so this is an example of another type of air tightness areas, whereby, for example, in the marine industry, so this is like not just a seal door, but the hatches, for example. This one in the marine industry, they actually follow certain ISO standards, and that's why it's pretty stringent that they want to make sure that the air tightness or water tightness is there. Okay. But many a times, I think for customers, once they install, okay, after they have actually produced, in terms of their operations side, okay, as you know, still over a period of time, in terms of temperature, humidity, and how it's been installed, that might be exposed to different type of circumstances, whereby this can cause them to actually degrade, okay, or during the installation phase, there could be a certain misalignment. And the environment condition, when there's debris or this can cause potential point whereby leaks start to form. Okay, so what happens when leaks start to form in different kind of application means there could be contaminants start to flow into areas whereby it's controlled room. They don't want contaminants to flow in, but because of those potential leaks area or locations, contaminants start to flow in. Or sometimes they actually contain inside, there is a airtight seal in order to hold the pressure. Okay, so when there's leaks that form, that means there will be a pressure equalization. Then it's hard for you to actually maintain the pressure differential between two different areas. Okay, and the impact, in terms of the impact, would be very different. So depend on the application and also the industries, which I'll touch on later. So I'll give you some examples of what the impact would be. Okay. So basically, this looks like for example, a simple accessories, or look like a pen, very compact size. Okay. But when you go out to the customers, some customers could be, for example, application, looking to actually make sure the air tightness is there, so that they can actually save energy for their operations. Okay, some could be more for the product quality department. So they have always a procedure. If you check with your customers in the QA/QC, so they might have actually procedures, which I know of, that they actually do inspection of their critical equipments, because those equipments actually produce the finished product, which are important. Okay, so if they don't actually ensure the quality of their machine, means the production might actually fail to actually produce the correct yield. Okay, so let's say for chip manufacturing, for optical kind of precise production in terms of the film coating of the optical lenses, for example. These are some of the machine out there in the industry whereby these are very critical. So in terms of those equipments, they might be actually contained inside the vacuum area. Okay. And also, I think I also emphasize not just about the maintenance or quality. So when there's a problems, issues, or people start to do warranty claim, etc., right, or investigation, so they might actually need to do failure analysis, where's the fault actually lies. Okay, and also for the design department, I think the prototyping or R&D part can actually comes in, whereby we can actually easily use this cost-effective solutions for them to actually do testing. So over here, okay, here is just an illustration for you. So we are not limited in terms of the okay, so I'll touch on from the left to the right. So in terms of the industry, whereby we approach in the context of unpressurized system, okay. So these are some of the conventional or even current methods that people are actually using. So you might actually come across customer using humidity sensor or even tracer gas. Okay, so when they inject tracer gas, they need to use a gas detector, okay, to actually pinpoint the presence of the gas, so that they know that there could be a leak. Or some people actually do inject a certain pressure into this area just to see from the gauge whether it actually holds the pressure, for example. And this is actually a smoke way, okay, and some other non-imaging ultrasonic, or even utilizing the probe way. But as you know, based on your experience, using the probe way, they have to actually go point by point, and it's definitely more time consuming than using the imager method. So as a whole, typically majority when they go into the conventional way, as if follow my cursor, so they actually go into this setup process. So they must actually go into the right setup facilities in order to have that correct environment settings before they can actually inject the right media that they want to provoke, okay, into the design device under test, for example, a DUT. And after that, they bring the detector, the correct detector, based on the media that they actually injected to actually detect. Okay. After they detect, I think always the challenge, some people don't have the right tool. It's hard for them to pinpoint because they cannot visualize. Okay. So example, by hearing or by using other methods, they might have actually a challenge, okay, in terms of pinpointing exactly the locations, okay. So most of the time they might actually do tagging, then after that ask someone to actually fix it, okay, and after that they repeat the whole entire process from the setup phase. So all in all, this one can be, depending on the application, you can spend a few couple of hours just for a test subject, okay. So we are trying to actually speed up the whole entire process by offering customers an alternative way. So alternative way will be coming here using the sound beacon, which is the SB140, to offer to the customers an alternative way. Okay. So with the ultrasonic sound beacon, okay. So here are just some of the images whereby this sound beacon is actually placed inside. Okay, so over here you can see some automotive, some vehicles, some aircraft, for example, whereby once we turn it on, using our acoustic imager, we are actually able to actually visualize exactly where the locations is, document it digitally, and for them to actually assist customer to actually shared even to their clients or customers or their OEM, etc. So in terms of the benefits or returns to the customers, okay, first thing first, I think in terms of the labor-intensive way of going through some of the current methods or traditional methods, if you actually go and visit some customers and actually notice or observe how they have been doing it, many times they need multiple people to get it done faster, okay? So to actually inspect, okay? So, and I think when they actually go into using acoustic imager, it's definitely what we want to achieve, help them to reduce tremendous amount of time. Less people actually is required as compared to their current method, okay? And also this way, definitely, they will be wowed by it because now they can actually find out the root cause as visually they can see exactly or pinpoint where the issue locations are. And lastly, of course, the intent is to make it easier, cost effective at their current site. So much easier, just place it inside. Okay, they can induce this frequency sound so that they can actually improve their quality process. Okay, and reduce definitely the warranty claims, especially for those branded kind of in terms of the brand reputation is important for the company. So I think having this said, I think some of the customers like ISO 9001 or this can be part of their department whereby they are very interested to actually propose to their production team or their other departments to actually look into this area too. Okay, so after introducing the product, I think the next few slides I'll be touching on some of the application, but just bear in mind, don't limit yourself to what I've actually shared because it really depends on what industry you are going after and what is the customer, because the industry, even aviation, for example, as you can see, aerospace, it depending on what part. Is it the MRO phase? Is it the assembly and testing? Or is it the aerospace adjacent kind of the industry whereby they do the parts components manufacturing? So yeah, it can be critical for that. Okay. So over here, this is just to give you some ideas. So for the aircraft industries, okay, so they do have the air cabin pressurization test that they actually have been doing it. So they actually inject a low pressure into the cabin after they actually basically shut the cabin door. And after that, outside, they actually use for example, ultrasonic probe or some other devices trying to detect exactly where is there a leak based on hearing the sound. So as you can see, the aircraft itself, if we are taking it as a whole, the body size, etc., and the number of doors or cabin compartments is pretty a lot. So it's going to be very time consuming based on the length and size of the parts that they have to actually do inspection. Okay. So having the acoustic imaging as a way and together with the SB140. So right now they don't actually have to actually pressurize the cabin, for example. First, they can do the initial phase whereby they can just put the SB140 inside, okay, the cabin location whereby they want to actually do the testing on and face it towards the door, for example, and over outside, someone will actually do the acoustic imager to actually see. Okay, so this is exactly what they can actually visualize. So this is definitely very critical, okay, in order, especially when the aircraft takes off into the very high altitude area, the cabin door must be very airtight in order to hold the pressure inside, okay? There's also other parts in terms of, for example, the aircraft, if you probably do it when you visit the customers. So some customers could be very critical in terms of the pitot-static system. So pitot-static system usually outside the body, you will see something like this over here. So over here, it's very critical pitot system because it actually is used to actually measure this, for example, the speedometer of the aircraft speed. Okay, so imagine it gives the wrong readings for accuracy because of due to leaks. Okay, because when there's leak, there's a pressure, because basically they are using pressure differential in order to actually the speedometer indicator will actually reflect the speed. Okay, so one way, for example, if let's say customers detect, oh, my pitot static system might have a potential leak. Okay, what's the other alternative that we can actually propose to customers could be using this. So over here, the SB140, if you can remember my previous slide, for example, over here. So this is a standalone. So most of the time you'll use this on its own for compartment space, okay, without this probe accessories, okay. But this probe accessories comes as standard, so which means you can actually screw on to the tip of this. Okay, so this one is to help us to actually focus on areas whereby you cannot put this thing inside, but you have a small openings whereby they can actually do a workaround for us to actually do the injection of this sound into the system. Okay, so that is why we have these additional accessories to help customers circumvent the challenges. So over here you can see, okay, so you can have a tube whereby you connect. So this tube, this diameter is about, if I recall, it's about 1 inch. No, 1 inch long, and if I recall, it's about 10 mm. Okay, it's about 1 cm diameter, external diameter. Okay, if you need that information in order to fit the right tubes, okay, onto this probe tip. So if you see the dimension that I actually sent out, so this is actually a very compact size SB140. Okay, so which means in the customer's point of view, let's say a piping, etc., which has a pretty small diameter, internal diameter. So you have to actually see the diagonal of this this square shape SB140 to see whether it can actually fits in. Okay. So coming into another areas, okay, just for you to actually explore and discover. So this will be more into the automotive space. Okay. So for the automotive space, as you can see, there's a lot of different sub-tiers suppliers, whereby they actually provide the different parts, all the seals, the windows, the doors, etc., and provide to the assembly center, whereby this actually is assembled. So after they assemble already, they have to actually do some tests. Okay, so to actually make sure that this is actually watertight, for example. So this process, typically what they call is actually a rain shower test. Okay, so as you can see at the bottom of this picture, you can see two vehicles going into a facility has this capability to actually do this test. So most of the time, in terms of this facility, is away from the manufacturing or assembly center. Okay, so which means to say, after they actually assemble all this, they have to send to somewhere else, another factory, to get this facility to get it tested. Okay. So alternatively, okay, instead of customers going through these tests, maybe initially before they actually spend the time going to these tests, and after that it fails, they can actually do this initial phase whereby they can put this SB140 inside the vehicles. So here are two examples. One of the passenger vehicles, and one is the commercial vehicle, like a truck, for example, whereby it's placed inside the compartment, okay, and it's turned on, and that's where we can actually see any potential leak. Okay, and get it fixed first before we spend the time to actually sign up for this final test. So overall, I think in terms of the feedback from the customers, if we were to actually look into their current process, it takes about very, very long. Could be just to complete test, could be 2 hours plus long. If you remember the setup, the inject, the test phase that I actually shared to you, I think there's about 7 steps. So overall, it's about 2 hours long. Okay, so with this method, the test was done for different areas of compartments. So not just the window shield, but actually at the back of the door. So depending on the design of the vehicle itself. So this one we actually cuts down to 20 minutes. So it's exactly a very significant time savings for the customers. So here is just more example. So this is the current method. So after rain shower test ready, so how do they know whether there's any leak? So they use a moisture meter, then go open up the boot of the car or door just to test and sense, hey, whether is there any moisture, how's the moisture level? So if the moisture level is high, then detect it, then they can actually understand that or determine that, hey, there's actually the seal integrity may not be there. Okay, so right now the problems will be lies in, oh, where exactly is that leak location that they actually have to find, which is a challenge for them. So they do not have it. So finding the root cause is what we want to actually propose to the customers then. Okay. So another one would be more into the automotive. So if you have customers, okay, as I shared to you, the finished goods or products for your customers are all very different. So you really have to show interest for all your customers that you have been visiting. Try to check with them, what are they producing, what parts they manufacture. Try to get a sense of how critical those equipments or machines or things that they are actually producing, and what is the process that involves behind the scene. That means what equipments are being used to produce those. Yeah, this will give you some clues or signs of potential things to discover. And after that, you can actually have a chance, probably meet up with their quality department. Okay, so because usually when this one fail, which definitely there will be some parts, okay, that actually fails. So try to find out what is their current process before you propose whether our solution is the right fit for them. Okay. So here is the actually example of a truck axle. So truck axle is critical, okay, the fuel, because most of the time, for example, truck axle might actually encounter oil leak. Okay, so for new parts like this, okay, in order to detect exactly which part actually is causing the leak, okay, so current method, some people actually use very expensive tracer gas injection. So example using helium, okay. So, and after that, they have to test point by point to find out exactly the locations. So we are providing them another alternative way. So using the SB140, because it's very compact. Okay, so in terms of the diameter, okay, so I'm using triaxle as an example. It can still fit into that internal diameter, okay. Or if let's say there's an opening, you can add in the 1-inch probe accessories on top to actually do the right fitting. Okay. Okay, aside from that, okay, where seal is very critical, so there's always the emerging space whereby, as you know, EV is growing, is getting more common, okay, and also their adjacent industry, there's the EV battery, is also revolutionizing, okay, so they are coming out with different models, different designs, okay, different compartment design because it has to fit into the different vehicles. Okay, so going into this kind of phase whereby there's always a potential whereby if you look into their development or prototyping phase or even their manufacturing side, if you check on them, the seal integrity is very important. So seal testing. So there's always a conventional method whereby they inject the helium test, okay, in order to do point by point testing to actually see, okay, which part of the compartment is actually leak. Okay, the risk is that if let's say if there's any leak for EV compartment battery, okay, EV battery compartment, sorry, okay, so it can actually cause corrosion or the EV battery electrolyte or this can actually flow out, okay, or even the gassing, okay, which is toxic. So this is an example, okay, whereby the sound beacon is in action, whereby we use our acoustic illumination to detect. Okay, so this is actually applicable if and only if you have customers, for example, producing the compartment for EV car battery. So this is something you can actually discuss with them to see what is their current process, where they can test it, okay, during the assembly part. Coming to this, okay, the next one, so no longer about automotive. So here, I just want to cover more into the clean room. So in terms of clean room, where you can actually see in terms of industries, there's really a lot of different industries. So mainly, I think in the electronics, semicon industries, or even the biopharmaceutical, and sometimes in the aerospace industries, depending on what parts they actually manufacture, they also have a clean room. Okay, so if you take a look at clean room, what clean room actually does is actually is governed by a standards, ISO, if I recall, 14644 standard. So basically, it's very stringent, depending on what ISO class the clean room is. So that can actually indicates what is that number of particle size, okay, per cubic meter, okay, of the volume in that area. Okay, so the concentration is important. So for clean room side, okay, usually the clean room door, okay, even the window or this are airtight seal. Okay, they have to contain, once you shut down the door, for example, the pressure from the inside of the clean room and the external, for example, the corridor, have to maintain a pressure gradient difference. Okay, otherwise the contaminants might actually flow in. So in terms of the impact, so over here, as I shared to you, there's electronics, for example, pharmaceutical or aerospace. The impact, okay, when you speak to the customers, is not just uh, one risk or one problems, okay? So for example, for the electronics segment, if your customer is producing chips, okay, so this can actually impact, for example, the yield, okay, because it's a high volume production, for example. So any contaminants that goes in or dust, particles, etc., especially for sensitive electronics, can definitely impact their product quality. Okay, this is undesirable. Okay, so and for example, if you go into pharmaceutical, why they have a clean room? You can even check with the customers and okay. So for pharmaceutical, they do have clean room inside. So depending on whether they are doing any form of drug manufacturing, for example, okay, product safety is involved. So yeah. So and also, for example, in the aerospace industries, there could be a larger facilities areas whereby they have a clean room environment where they actually start to actually assemble, okay, the aircraft engine, okay, or critical propulsion systems that they cannot have any contaminants to actually go into the area. Or even customers have areas whereby they do the, for example, the optical manufacturing. Yeah, okay, so that is not limited to only these three industries. So where you can actually find this clean room. Okay. So the potential is broad. So without stopping the operations, because currently, if let's say, for example, they want to actually get a clean room tested, usually they engage a third-party services, then they have to shut down and there will be downtime, okay, in order to pinpoint the location. Okay. So without stopping the operations, a quick way for them to do quick verification, you can even offer them this way for them to actually pinpoint to troubleshoot, actually find any issues. Another part is, okay, we also explore into I think the common ones that we always go into for electrical space would be the electrical cabinet doors. Okay. So if you look up, I think electrical cabinet door is very critical. Okay. If the seal is poor, what happens next? Okay, so debris, your dust, your moisture, everything start to get in, and inside here, this compartment is all those like electrical components. Corrosion start to happen depending on humidity kind of environments. This cabinet door is being installed at. Okay, so hazard will start to hazard is definitely electrical hazard will definitely be a risk, like short circuits can actually happen or any form of compromised electrical components. Okay. So for example, if you have customers doing the or producing the electrical cabinet doors, for example, okay, so when they close off, okay, it should be a tight seal, and putting the SB140 inside, you can actually use our workstation imager to actually pinpoint, okay, for them to verify, giving the customers or even the supplier the higher confidence, or even the customer side, they can use this method to do a form of quality check before they buy off. Okay, usually they buy off quite a lot. Okay, so yeah, so this can give both parties a way of assurance. Okay, with our Fluke product solutions. So coming to that, okay, what about the consumer goods? So companies that, for example, okay, all these appliances, shall not name any brands, okay? So consumer products, okay, whereby our daily household appliances like a fridge, freezer, refrigerator doors, for example, okay? So brand reputation is important for the customers, and any seal leak, okay, is unwanted, okay? Especially the last thing they want to hear is too many warranty claims, or even recall back all the different their consumer goods. Okay. So here are just some images whereby the SB140 is placed inside, and this is where we test pinpoint the location it is. Okay. But for us, if let's say you're going into the industrial equipments, also potential. So not just white goods about the household appliances, but you can actually explore into equipment manufacturers. So people who actually produce equipments whereby they have to, for example, a vacuum coating machine, okay, for film coating, for example, all these are very critical system, very expensive system. Okay, they have to hold, for example, a certain pressure or vacuum inside that area, inside the machine for their production phase. Okay, in order to attain the precision, accuracy, and also to remove any contaminants. So as for marine, okay, so marine, so when I refer to marine, okay, so it's more into, for example, the vessels, all this, right? When you find on the ocean, the cargo, for example, okay, so there's a couple of parts where we go into it. So one is the vessel itself. So the vessel, there's doors, the bows, okay, there's installed what we call the stern doors. All these have a very airtight or watertight seal. Okay? And be it in the exterior front or internal door is critical for them to make sure that water doesn't seep in. Okay, you will actually damage. For example, if let's say there's a cargo goods, okay, water can actually damage the certain critical goods, whereby it's undesirable. Okay, so, and also for container itself, here is an example of different ISO standards. Okay, some containers itself is also ISO certified. Okay, 1496. Here's an example. Okay, so what it actually goes into to make sure it's certified for the proper testing, to make sure that it's actually watertight, sealed. Okay, to actually be able to actually hold it and or prevent the water from seeping into the containers whereby the customer's cargoes are inside. So for SB140, here's an idea for you to actually, in terms of most of the time, for example, in the dock, for example, or even customers along the way, they suspect there could be certain leak. So they don't have to inject any pressure into their vessel, for example. They can just put for example, they close the door, the other side, they put the SB140, or on the other side, they use the acoustic. After they close the door, they can actually do the inspection to see which part of the door has any potential seal defects. Okay. So coming to how to use it, okay? So for how to use it with the SB140, okay, if you have it on hand, okay, so this is actually a hardware, okay, it doesn't work with a software, okay. So once you put a 9-volt battery inside here at this end, okay, so there's actually a knob over here. So you unscrew it, you fit in the 9-volt battery. After that, you screw, tighten, you just turn on, and it works. So in terms of how you can actually utilize it, okay, because it's very compact size, lightweight, you can pretty much fit into even a small size compartment area. So you just put it inside and close it, and use the acoustic imager to actually see from the exterior side, okay, of the potential leak area. So this is actually a workflow in our quick reference guide, which also comes together with the unit. Okay, so customers can actually follow the guidance. Okay, Another part is, I think the 4B is the one. Okay, so the 4B is whereby customers, if and only if customers have certain openings, whereby for them to actually inject, okay, using our accessory probe, sorry, which is about 10 mm thickness, okay, for them to actually do the injection into this enclosed area if they cannot put this inside the compartment. And earlier on, I mentioned about the sound beacon mode. Okay, so for beacon mode, it applies to the II 500, 905, and 915 models. So when, in order to activate this, if you have the older version of the firmware, okay, so what you need to do is on your device, for example, okay, you connect to the Fluke Connect desktop, okay? That's one of the easiest way, okay? So once you connect, you actually prompt you whether you have the latest firmware. If there's a latest firmware, it will actually prompt you please actually, they will show you, do you want to download this firmware version like 6.1.6 version, 0.67, for example. So you press download, and after that, you press install. And after install, you have to reboot this acoustic imager. After you reboot ready, then over here, the left-hand sidebar, you will see the beacon mode that's added on in the last item. So with beacon mode, what it actually does is, okay, so when you tune to beacon mode, okay, so this is a filter that we actually filter up. So we actually zoom in into the 30 to 50 kilohertz range, but the box up areas will be within the 40 kilohertz plus minus 2, okay, kilohertz range. So this will be the instance whereby anytime customer wants to switch the different mode, this makes it a very seamless process for customers to actually tune to different needs. Okay, so over here they create a folder, what is the application for, so they can actually save it as a shortcut. Okay, in terms of profile. So when you use, okay, just want to emphasize, when you use SB140, it's nothing to do about using it to measure what's the leak rate. So there's no need to use but the Q mode, etc. As for the list, inside our data sheet, I think we have a couple of this kind of summary, okay, in terms of the certain application space. But bear in mind that, as I emphasized, so the customers, the personas that you are going after can be very different from your current existing ones, but it can be within the same company, but different department, whereby they might be very much interested in this, okay? So offer them an alternative so that they can actually consider it, okay, to actually improve their whole process. So, okay, so we actually consolidate some common FAQ for the SB140. So here are just some, just to reiterate, okay, to emphasize the beacon mode, update to 6.1.6. Okay, if you don't see it, try to install, update to the latest version. Okay, the i900 and the previous model i900 and 910 don't have the beacon mode, so it only applies to the 500, 905, and 915. Okay. So don't have to use NICU mode for this case. Okay, and as for the probe tip, okay, so just now I shared to you the image. So you put the additional accessory probe tip is only for a certain situation whereby you cannot actually fit into the compartment. Okay, so with that, I've come to the end. Okay, sorry, slightly overrun a bit. Okay. Is there any questions?
Yeah, Jake, I have a question.
Yes,
Romel
I
here
think it's
from
Romel,
RS.
yeah.
Yeah. Okay. I have what do you call this? A customer that who are this under the automation and then want to check this because you have mentioned that this
Yeah.
SB140, right, are for those non-pressurized. Okay, the customer want to check the oil engine. Okay, in off mode or unoperational. They want to know if there is a leak coming out to those the plug of this oil engine. So is our SB140 able to do that?
So when the oil, okay, so just an example I shared to you is when, for
Yeah.
example, the oil is not filled. Okay, so for your situation, I would assume that the oil engine has the oil contained inside. So the
Yes,
challenge is
correct.
when there's a oil or water. My understanding in terms of physics, you will actually attenuate the sound that is traveling through it. So it really depends on the design of what's inside that customers how it actually flows from the start to the end point. Okay, so probably we can understand how this can actually work for the customers by doing a demo. If let's say after you do a qualification of the customers, okay, assess what's the exactly the areas in terms of the car engine, the truck engine, for example, from the start to the end, and which is could be the potential lead source. Okay, and before you actually conduct a demo.
Okay.
Yeah.
I already conduct the demo
Mm,
for
mm,
this inquiry using the previous I mean the one that I have, the 910. Okay, and
okay.
then because the customers experiencing that there is a small amount leaking, which is
Yeah.
passes out to this oil
Mm,
engine plug. They want to determine if the oil, I mean the air leak or the leakage are coming outside this plug or someone else. Because we need to provide the solution. It's either the plug itself that covers the engine oil, because they don't want to have this small amount of oil that
mm.
comes out to that engine.
Okay, okay, Romel, it helps me
Yes.
if let's say probably we can discuss to I need to have a better visualization of the schematics of how that customers when you say about the plant. Okay. Yeah. So in order to pinpoint where they are actually seeing the leaks currently, and because their current state they already have oil field in it, so there might be certain layers of oil over there. So yeah, in order to help customers to diagnose whether this is potential.
Okay. Maybe I will discuss this you
Yeah,
offline and then provide you
yeah,
some photos and then the scenarios also to visualize the issues.
yeah. Can.
Ken, thank you.
Yeah,
Yeah. Maybe here I
yeah,
add
yeah.
some points here.
Yes.
Maybe you guys, this Jeremy here from Singapore. Just to add on is when we launch the acoustic camera, we are looking at leak, we are looking at partial discharge, and we are looking at mechanical problems. So all this is when they check, they try to detect the leak that is present in the facility. But now we are going into a white space where we are looking at QC tests, or when during the manufacturing time, manufacturing process, or is that or installation process or commission process where there is some not system that is not installed properly, or there's some quality problems. So this is definitely a white space for us to push the acoustic camera. Okay, so you can also look at something like the in the semicon industry where there is, or other industry that has many poisonous gas. Okay, so they in many industry that some process they need to use poisonous gas. So the installation and commissioning become very critical. So this is that area where you can actually introduce this type of solution for them to inject the sound into their installation to see any leak, and these are something that will be very critical for them, and then something that can make their job easier and safer. So this is another angle that you guys can take a look on. Yeah, that's all from my side. Yeah, thank you. Yeah.
Thank you, Jeremy. Yeah. So I think in summary, just to round up, when you approach for these opportunities, I think it's definitely to customers who exactly in their companies is interested or has been facing issue with the tightness quality testing or checking. That could be one clue. Okay. And definitely, you also need to speak to the right person. Sometimes the maintenance people, if you ask them, they'll say no, because they do not know what exactly goes behind the scene for another other department's process or procedure. So I think with that, I've come to the end. If you have any questions along the way, do reach out to me, okay, via email or on the phone, for example. So I will send you the deck after this session. Okay, thank you so much, everyone.
Thank you so much. Bye
Thank
bye.
you.
Thank you.
Thank you.
Thank you.
Bye.
Thank you. Bye. Have a nice day.